Lesson 3.4 is Pythagorean theorem and trig ratios. Hopefully remember Pythagorean theorem finds a missing leg of a right triangle. It's a squared plus b squared equals c squared. The a and the b come from the legs of the right triangle, whereas c is the hypotenuse. So in this first example, I'm trying to find this missing leg because the legs are the two sides that make up the 90. The hypotenuse is always across from the 90. So I would have 2 squared plus x squared equals 4 squared. That would be 4 plus x squared equals 16. Subtract the 4 from 16, and that would be 12. And then to get x alone, I would have to square root, and you need to simplify your radical. So within 12, there's a square root of 4 times the square root of 3. Square root of 4 would become a 2. So this side would be 2 square roots of 3. They always want you to simplify. Okay, on the next example, these legs are actually congruent. So this would follow our rules for special right triangles, but we haven't talked about that yet. So I'll just do Pythagorean theorem. I'm trying to find the hypotenuse. So I'd have 8 squared plus 8 squared equals x squared. That would be 64 plus 64, which makes 128. And I would have to square root that. Well, I already know that 64 doubled made 128. So within 128, that is a square root of 64 times a square root of 2. That would become 8 square roots of 2. Okay, so then we go on to the 6 trig ratios. The basic 3 are sine, cosine, and tangent. Remember that's so. So sine is opposite side over hypotenuse. And remember, theta is always the angle. So it's sine of an angle equals some ratio of the sides of the triangle. Cosine, ca, is adjacent over hypotenuse from whatever angle they're talking about. And tangent is toa, opposite to adjacent. So in this problem, I don't have to do Pythagorean theorem. But if you were ever missing a leg, you could, of course, do that to then use your ratio. But this first one says sine of A. That means I'm looking from this angle. So picture standing here, and I want the opposite over the hypotenuse from this angle. So opposite would be here, and then this would be my hypotenuse. So it would be 6 over square root of 45. Can't have radicals in the denominator, so you would rationalize. That would be 6 square roots of 45 over, this is 45 squared under a square root. They cancel each other out, so that would just give you 45. Now the problem is, too, that this 45 needs to get broken up because there's a 9 times a 5. So that would become 3 square roots of 5. Well, this 3 gets multiplied by this 6 that's already out in front. So 6 times 3 is 18 square roots of 5 over 45. Then I can still simplify because I can take out a 9. So that would be 2 square roots of 5. That's 45 over 5. If you wanted to, you could have broken this up here into your 3 square root of 5, and then you would have just multiplied by your square root of 5. Might have been a little faster. All right, number 2 is cosine of A. So again, I'm standing from here. Ca, so I want adjacent. That means the leg that is touching or next to angle A. That's not the hypotenuse. That would be 5 over the hypotenuse, which is 10. So that simplifies to just a half. Pretty simple. All right, number 3 is tangent of A. Tangent is toa, so I need opposite side over adjacent side. So next to it. So it would be square root of 28 over 6. I need to break up square root of 28 into square root of 4 times square root of 7. That would be a 2 square roots of 7 over 6, and then reduce your 2 6 to a third. So that would be square root of 7 over 3. So those are the 3 basic. Then we get to the reciprocal trig functions, which are cosecant, secant, cotangent. Cosecant is just 1 over sine. So what that means is it's a reciprocal of sine. So it's hypotenuse over opposite. Secant goes with cosine. So it's hypotenuse over adjacent. And then cotangent obviously goes with tangent. So from angle J is where I'm looking. I want cosecant or hypotenuse over opposite. So it'd be 73 over 48. I'm sure that can't be simplified, but if you wanted to check, do 73 divided by 48, hit math, change it into a fraction, stay the same. That tells me it does not simplify. Okay, number 5 is secant. Secant goes with cosine, so it's a reciprocal of cosine, where it's hypotenuse over adjacent from angle T. So that would be 29 over 20, should be reduced. And then the last one is cotangent of y. So now this time our angle is up here that we're looking from. So this is our opposite, this is our adjacent, this is our hypotenuse. So we want 36 over 77. And I don't think that can simplify either, so that should be our answer.